CPUs, processors, systems on a chip. We've all got them. What do they do? What are they for? And what kinds are there? This is Pocketnow. I'm Joe Levi. That's what we're going to talk about on today's episode of the Android Guy Weekly. So buried inside your tablet or your phone is something called a processor or a core or a system on a chip. What do those all mean? Well, for that, we're going to go back to computer technology and terminology. Way back in the day, a long time ago, in the 90s, we had computers, just like we had today. They weren't as fast, but they had all the same parts. Kind of. Those parts, well, I had a CPU, a central processing unit. That thing did, well, almost everything, except not all that much. What it did was it processed instructions. That's all that it was meant to do. People thought it was really important, and indeed it was, but it wasn't as important as they thought because they had a whole bunch of other chips on their motherboard. You like that? Tech jargon up the wazoo in this episode, huh? So they had a whole bunch of other chips. They had an ALU, an arithmetic logic unit. They had a memory controller, which ironically controls the memory. They had all this other stuff, a Northbridge chip that controlled the top side and more important parts of the motherboard, and a Southbridge that controlled, well, the lower side and the less important parts of the motherboard, and all this stuff, the peripherals that plugged into them. There were lots and lots of chips. The nice thing about that is you could customize, if you were a manufacturer, what you wanted on your motherboard. So you could really differentiate. You could make a whole bunch of different stuff and make your stuff stand out from your competitors' stuff. The CPU, on the other hand, that was something that they said, we'll let the end user have a little bit of control and flexibility and pick what they want. To a certain extent that worked, and that metaphor carries through even through today. Well, as things progressed, we started getting more and more stuff on that CPU. For example, today we have a CPU that not only has the CPU on it, it has the ALU for processing arithmetic, it has the memory controller in most cases, and some other stuff. There are even multimedia extensions. Remember those Pentiums with MMX? Yeah, that's what that meant. Nobody really ever knew at the time, but that's what it was for. So we've got all this stuff, and it's building it all into one chip. Well, that means there's less flexibility on the motherboard side to customize and to add different features and benefits based on, what the Southbridge is and does, or how powerful the ALU is, or what the Northbridge is. But we kind of kept the Northbridge and the Southbridge separate on desktop computers. We'll come back to that in just a minute. The advantage is one chip did a whole bunch of stuff, and it did it faster, especially when you're talking about the memory controller, because you're really pumping memory in, or stuff from the memory, into the processor, processing it, and then spitting it back out to the memory, out to the RAM. That's pretty much, a day in the life of a CPU. With the memory controller, even right next to the CPU, slows things down. Put it on the CPU, wow, it goes really, really fast. So you've got cache, you've got memory, you've got all this stuff built in, and it's really, really good. It makes the chips smaller, there are less chips, that makes the overall system less expensive, though it makes that CPU more expensive. Okay, enough with desktop PCs. All right, great. We're going to talk about one more thing, but we're going to compare that to where we are with our Android tablets and really most of the other smartphones and tablets out there today. You see, these devices, these computers that we sit on our desks or have on our laps, they're what's known as CISC chips. They're complex instruction set computing. Sounds really, really neat, doesn't it? Okay, what about our phones? Well, phones are based on RISC, reduced instruction set computing. Now, the differences between those two are, well, night and day. One is really, really wide open. You can do anything you want with it. You write these really complex instruction sets, you send them to the processor processes all these complex things. And, well, the more complex something is, the longer it takes to process it, but it can do it. It's flexible that way. RISC, R-I-S-C, it's reduced. It's not as complex. Because of that, it doesn't have to run as quickly to accomplish the same things, but it pushes the processing of the complexity over to the code. So you have to take complex code, somehow reduce it, send that reduced set over to the processor thinks about it, does whatever, and spits it back out. But you can get a lot better speed out of it as long as the software that's pre-processing the complex instructions to reduced instructions is really efficient. It's a little bit of extra overhead, but it has some advantages. So one of the most popular architectures of RISC processors is called ARM. It used to stand for something, but nobody really cares anymore because it's just ARM. ARM makes a design. That's about it. Yes, they make some reference samples, but you can't just really go out and buy an ARM processor. You can buy somebody else's processor that's based on ARM. So there are a lot of different versions of this ARM architecture. We're up to version 7 right now. I know it's going to get kind of confusing. ARM v7, it's where we're at. It's 32-bit. Honestly, almost everybody uses ARM v7. You'd be surprised. Let me read you this list. TI has their OMAP 4. It's an ARM v7. Exynos, that's Samsung, ARM v7. Snapdragon, ARM v7. NVIDIA's Tegra, it's an ARM v7. V8, it's going to come out sooner or later. They're making a lot of progress. It's 64-bit. It adds a whole bunch of more stuff that's going to make things just tons and tons faster. But where are we today? We're at ARM v7. That's not bad because ARM v7 has lots and lots of different levels inside of it. In fact, you're familiar with the Cortex name? So we've got the Cortex A8, we've got the Cortex A15. These are still v7, ARM v7 chips. What do they do? Well, honestly, I could devote hours to that, and I'm sure I would put you all to sleep. I don't want to do that. You can go and research what each one of those does and why it's different and the benefits. What we're going to talk about here is more high level. You see, TI makes their OMAP 4 based on the ARM v7. And depending on which OMAP you're talking about, it includes a different Cortex, version of the ARM Cortex. So there are just a lot of variables and everyone would get confused and lost really fast, me probably first. But the difference is between desktops and mobile processors, we're putting even more stuff onto the mobile processors. Instead of just taking a CPU and an ALU and a memory controller, well, over here on these SoCs, these systems on a chip, we're putting not only those, okay, so we've got the CPU, we've got the ALU, we've got the memory controller, we're usually also putting a GPU, a graphics processing unit, a video card right on the chip. We're usually putting the North Bridge on the chip and the South Bridge on the chip. Many times we're also putting our cellular antenna processors, those chips, onto the CPU, the whole system on a chip. Now the advantage there is it's one chip. So you'd think that combining everything onto one chip would make things easier and simpler. Well, it makes things smaller, it makes things more power efficient, so you need smaller batteries, or your larger batteries can last longer to run them. We won't get into that argument, we've already had that, haven't we? But the disadvantage is now you're differentiating based on that one chip. And unlike desktop PCs, you can't simply pull the chip and replace it with another one. Wouldn't that be cool? Hey, you know what? I don't like this TI OMAP that I have on my phone. I want to go with a Tegra 3, so I'm just going to pop it off and pop my new one on. Wouldn't that be cool? And I have nothing against TI OMAP, by the way. I'm just using that as an example. But we can't do that. They're soldered on the board. They're buried underneath circuitry. You just can't do it. So you have to get a new device. That's kind of the other side of that coin. Yes, you're saving money up front. Yes, you're putting a lot of stuff into one package up front. But when you want to upgrade or when you want to change, you have to change the whole thing. It's a system on a chip. You got to replace the whole thing. And that unfortunately means your phone. So where does that leave us? Every different manufacturer of processors, not of phones, is doing something different, but most of them are using this ARM architecture, and they're usually paying about 7 cents for licensing per unit to be able to license that architecture. They're adding their own stuff to it. Again, this is a system on a chip, and ARM is just the CPU. The Cortex, that's the other stuff that's added in. Okay, not to be too terribly confusing there. So TI is doing their own thing. They're putting particularly signal processors, because that's what TI does best, in with their SoCs. Samsung's Exynos, and before that the Hummingbird. They're doing all kinds of cool things with theirs. The Snapdragons. Need I say more? I mean, come on. That's what everybody uses. HTC, Dell, Sony. Wow, they're great. And then, of course, NVIDIA's Tegra, which are powering some of our higher-end tablets and some phones. Do they have any for phones yet? I know they were going to. Sorry, NVIDIA, I just had to jab at you a little bit there. But everybody's doing something different, but they're all starting from the same foundation. Now, when that foundation improves, we're going to see some new cool stuff come out from all of these different manufacturers who are just using ARM as the foundation upon which they're building everything else. So really, the discussion is more about ARM and how cool it is, but because it's this whole system on a chip thing with all the extra additives built into it, Bluetooth 4 versus Bluetooth 2.1, Wi-Fi N versus Wi-Fi G, all that stuff, and of course what video processor they're using for graphics. That's the cool part. Hopefully I've removed some of the cloud and mystery around CPUs and haven't added more to it, but once we get this deep, it's hard to get really deep without, asking more questions than we answer. So, did I get your questions answered about CPUs and systems on a chip, SoCs, how they're related, where they came from, what they do for us, and some of their drawbacks? If I did, great, give the video a big thumbs up. If I didn't, or if you caught something that I said wrong, or would like to clarify or add more information, perhaps what you like best about your SoC that's powering your phone or tablet, head over to Pocketnow.com, leave a comment, let us know. Participate in the discussion and help everybody else who just got lost by everything I just said understand the concept a little bit better, because I'm sure you can explain it in a different way that I can, that others might be able to understand better. Complex topics, but that's one of the things we like about the Android Guy Weekly. For Pocketnow, I'm Joe Levi.